Welcome back to the Explainer. Let's jump right into episode 7.1, the integrated automation system, which is honestly the nervous system of the entire ship.
Okay, let's dive into this. Picture a massive, ultra-deepwater vessel like the GF-12,000 Drillship. We're talking about a floating six-story building of solid steel, right? Pumping out 42 megawatts of power, constantly fighting ocean currents with dynamic positioning systems in real time. With all of that heavy machinery running 24/7, the sheer volume of data it generates is completely overwhelming. You literally cannot have operators running around the ship checking individual gauges. It's just impossible. So every single alarm, every sensor reading, and every machine status across the entire vessel flows through one integrated system. Imagine thousands of tiny sensor nerve endings, from the absolute deepest, darkest parts of the engine rooms all the way up to the top of the derrick, all sending their data simultaneously. And get this, they don't just send it down one wire. They're blasting this data through two completely separate fiber optic pathways at the exact same time.
Which brings us to what this system actually is. The Integrated Automation System, or the IAS, is quite literally the vessel's central nervous system. It connects the engine control room, the ECR, and the bridge using a highly resilient, redundant, dual fiber optic data highway. To wrap your head around it, just think of the human body for a second. The sensors, those are your nerve endings detecting heat, pressure, pain. The fiber optic cables are your nerve pathways carrying those signals, and they deliver all of that critical split-second information straight to the brain of the ship.
Now, what's really interesting to compare here is the stark contrast in how these networks are actually designed. In an older, single-path network, the system is, incredibly fragile. A single cable fault, maybe a fire in one compartment, or just a severed wire, and boom, it instantly blinds the crew to what's happening in that entire section of the ship. But the GF-12,000, it operates on this philosophy of invincible physical redundancy. By using a dual fiber optic pathway, data transmits simultaneously across two physically separated routes. It is the exact same brilliant redundancy logic that they applied to the ship's dynamic positioning Class 3 systems.
Let's actually walk right through a worst-case scenario. Imagine the sheer tension of a severed cable, or say, a fire melting right through the primary fiber path. Instantly, step 1, that primary path fails. But before a human operator even has time to blink, step 2 kicks right in. You get an automatic failover to the secondary path. The system just instantly routes everything through the surviving cable. And the end result? Step 3, absolutely zero loss of alarm visibility. The operators sitting at their screens, they don't experience a single interruption. The crew is literally never blinded to what is happening aboard.
And when we talk about what is actually being monitored, the sheer volume is it's incredible. We're talking about the constant aggregation of highly specific, critical machinery parameters. The IAS is constantly pulling in real-time data on lube oil pressure, fuel system levels, high and low temperature cooling water, and exhaust gas parameters across all 6 of those massive diesel engines, and so much more. This isn't just a static snapshot. It's a continuous, second-by-second fire hose of data being processed and logged without dropping a single frame.
Now, all of this incredible data funnels into exactly 2 primary locations: the engine control room and the bridge. You can think of these 2 spots as the dual brain of the ship. Because they receive the exact same identical live feeds simultaneously, navigators and engineers are always looking at the exact same reality. There's no confusion, no radioing back and forth saying, "Hey, what does your gauge say?" They share one perfectly unified picture of the vessel's health.
But let's shift gears for a second and step right into the shoes of an operator. We know functionally what the IAS does, right? It moves data from point A to points B and C. But what is the real value of all this data? Why is this system considered so brilliantly designed? Well, the true power of the integrated automation system isn't actually just splashing a number on a screen. It's really about what a human being can do when all those disparate numbers are brought together in one place.
Think of it kind of like a modern hospital patient monitor. In the old days, a nurse had to physically walk around a hospital bed, checking a dozen isolated gauges. One for heart rate, totally separate one for oxygen, another one for blood pressure. It's slow, and honestly, it makes correlating those symptoms really difficult. But with an integrated screen, you see everything together, right there. The true power of the IAS is exactly like that modern monitor. It allows the operator to correlate multiple symptoms across entirely different systems, giving them the ability to diagnose an illness in the machinery well before a machine actually breaks down. And this brilliantly illustrates the whole point. Let's look at a real-world example straight from the ship's engine room. Imagine you're seeing a slow, creeping upward drift in your high-temperature cooling water. And at the exact same time, you notice a really slight decline in your lube oil pressure. Aren't 2 isolated gauges in 2 completely different rooms? Neither reading has actually triggered a critical alarm yet. They just look like minor, everyday fluctuations.
But viewed together on the IAS, they reveal a developing engine cooling or lubrication issue. It's an early warning that a single gauge on its own never, ever could have provided.
However, this incredible technological achievement does have a fatal flaw. And the crazy thing is, it's not a technological vulnerability at all, it's a psychological one. It's a phenomenon called alarm fatigue. This is a very well-documented human factors risk where operators simply become desensitized to frequent alarms. I mean, when you aggregate tens of thousands of data points, alarms are absolutely going to go off. But if operators start acknowledging or silencing them reflexively without doing a full investigation, well, that is when the entire multi-million-dollar safety net begins to unravel.
It is incredibly dangerous to treat repeated minor alarms on a single parameter as just nuisance noise. When a system chimes repeatedly for a slight deviation in, say, high-temperature cooling water, human nature is to just mute it. We want to call it a glitch. But these recurring alarms are frequently the absolute earliest indicators of a developing mechanical issue. They are early symptoms, not just system noise. Silencing them, it's literally like ignoring a recurring cough right before major illness strikes.
In fact, as the engineering training for the GF12000 explicitly notes, and this is a direct quote, the IAS provides the data, but its value depends entirely on operators actually engaging with it. This is absolutely crucial to take away from this. You can have the most perfectly engineered vessel in the world. You can have fully redundant DP3 systems, dual fiber optic highways, automatic failovers, the whole shebang. But at the end of the day, all of that physical redundancy is entirely dependent on the vigilance, the critical thinking, and the sheer discipline of the human operator sitting in front of that screen.
Which leaves us with this final, really critical thought to ponder. The IAS is a total marvel of modern engineering. It's capable of illuminating the darkest, most complex corners of a drill ship to keep the crew safe. And it faithfully provides the data, second by second. But what actually happens when operators become desensitized to the very system designed to save them? It's a stark, powerful reminder that in the world of extreme engineering, the most complex, the most fragile, and honestly the most important component of all isn't made of fiber optics or steel, it's human. Thanks so much for joining me on this explainer, and I'll catch you in the next one.